Hi guys, welcome again. This is me Muhammad Kashif Sahir. I came up with the new lecture series for you now. In this series we will discuss about the mathematics of 9th standard from Punjab textbook board, Pakistan. We will proceed this and we will do it chapter wise, and the first chapter we will do as matrices and determinants, which is the chapter number 1. Here we go. Our first topic from the chapter 1 from class 9th will be matrices and determinants. Remember, matrices is the plural form of matrix. Now question, what is matrix? A rectangular array or formation of a collection of real numbers, and we enclose them by these brackets, then that will be called a matrix. Rectangular array. This word rectangular is derived from a word rectangle, which is a shape. This shape in mathematics, such shape in mathematics is called rectangle, and this word rectangular is derived from this word. Next word is array. Array is simply an arrangement, but arrangement in a specific way, which is rectangular way. Just because of this, you will find all the matrices in rectangular form. For example, these are the numbers 1, 3, 4, 7, 2, 0, and we have enclosed it by brackets. This will be called a matrix. We rename or we denote the matrices by English alphabets, such as A, English alphabets. A, B, C, D, up to so on. Remember one thing, these letters have to use to represent any kind of matrix must be the capital letters, because the small letters like these A, B, C, D, these letters will be used later on in our examples and exercises, will be used as elements. And what are the elements? These internal numbers are called the elements of a matrix. This is a matrix. These are called elements of a matrix. These are called rows. If you consider this horizontally, this will be called a row, and if you consider it vertically, so vertically these will be columns, right? So column representation is vertical, and horizontally you can consider this row. Let me give you one more example to understand the rows and columns of a matrix, because it is important to understand. For example, I have two matrices A and B, and the elements are like 1, 2, 3, 4, and the elements of B are like A, B, C, and D. If I have to talk about the rows of A, I will consider 1 and 2 as the row number 1, and 3 and 4 will form the row number 2. And let's talk about the column B, the matrix B. In matrix B, A, C and B, D represents columns. So this is column number 1, this is column number 2. So horizontal representation are called rows. Vertical representation of a matrix is called column. Now let's get back to the point where we just left a while ago. We discussed about the rows and columns of a matrix. The rows are the horizontal elements of a matrix, and the column A are the vertical elements of a matrix. Now you will find sometimes the question written as find the order of a matrix. Here you let us say that M represents the number of rows in a matrix, and N is the number of columns in a matrix. So now order will be denoted by M cross N. Let us take this as an example, this matrix A. Here you will see the number of rows. This is first row and this is second row, and this is first column C1, and this is the second column C2. So there are 2 rows and 2 columns. So therefore M will be 2 and N will be 2. So the order will be 2 by 2. As per the topics that we have learned just a while ago, we are going to attempt some questions from the exercise 1.1 from 9th standard. Look at first question. Find the order of the following matrices. Question number 1, and first part is A. 2, 3, minus 5 and 6 are its elements. Likewise B, 2, 0, 3 and 5 are its elements. We have to find the order, and as you know that finding the order of a matrix, we have to write its formula first. Order of A will be M cross N, and as you know that M are rows and N are columns. Let's count the rows of matrix A. See, this is row 1, this row 2, right? So we have 2 rows here and columns. Column 1, column 2. So we have 2 columns. So order of A becomes 2 by 2. Next, same order of B will be same, M cross N, and as you know that 2 rows and 2 columns, so the same thing, it will be 2 by 2. Part G and H. Here same thing, order of G will be M cross N. Row number 1, row number 2, row number 3, column 1, column 2 and column 3. So these are 3 rows and 3 columns. Remember one thing, students, I just want to clear that you will not shade these lines that I am shading. It's just for you to understand how I am calculating these. Move to H. Here row 1, row 2. So 2 rows, column number 1, column number 2, column number 3. So 3 columns. There comes the order. So we have completed the first question and its all parts. Now let's move to the next question from exercise 1.1. Here you can see at the question number 2 from exercise 1.1, which of the following matrices are equal? Now we have to find out the equality of these matrices. As we have studied just previously, that there are 2 conditions to fulfill the requirement of equality of 2 matrices. And what are those? Let us see. So in order to check the equality of 2 matrices, we have to testify these 2 conditions, which is like, first condition is that the order of 2 matrices should be equal, and then the corresponding elements should also be equal, right? So let's go back to our question and check the equality of those matrices. We have to find out the equality of these matrices. In order to make it easy, let us check against the first condition. We will choose the parts which have equal order. So A, the order of A is 1 by 1, order of B is 1 by 2, so which is entirely not equal. So against A, let us check if there is any column, if there is any part which have same order 1 by 1. C. This C, consider this C. Now while we checked the order of A and C, we found that the order of A is also 1 by 1 and the order of C is also 1 by 1. Don't be confused with these. You might consider that there are 2 numbers in this C, but don't be confused with this. Look at the part B and see. there is a space between the B here, 3 and 5. There is a space between these two elements. Here this is only one element. It says that 5 minus 2. If we will solve this, 5 minus 2, it will give us 3, which is the only one element here. So that is why order of A, see, order of A and C is equal and 1 by 1. Yani each of the matrix have one by one order. Now we have to check the corresponding elements. Note one thing, if we solve this, if we subtract 2 from 5, it will also give us 3. So condition number 1 is testified, condition number 2 is testified, yani both have corresponding elements. There is only one element in A, one element in B, and both of them are 3 and 3. So we can say corresponding elements are also equal. Hence, matrix A and matrix B are equal. Right? Now let us check the B. Matrix B has 2 elements, yani 1 row and 2 columns. The order of matrix B as you see, there is 1 row and 1 row and 2 columns. So the order of B is rows 1 by 2. Remember, in order to just make it precise or short, we can write the order of a matrix just at the base on the on below of the matrix. Now let's talk about another part, next part, which is D.